Hello and welcome in this new video. It seems that the translation of array structures into assembler language remains an area rarely addressed in the resolution of exercises relating to the course of the pedagogical machine. For this reason, I will try to translate a small program written in C language containing an array structure and which clearly shows the operations codes used in the equivalent assembler program. My name is Balach Mohammed and this tutorial is intended for first-year students, MI, Computer Science Department, at USTHB. Given the following program, written in C language, containing an array structure, we are looking to translate this program into a new equivalent program written in assembly language, using simple operation codes viewed in Pedagogical Machine chapter. If you haven't watched the related videos yet, I warmly invite you to check them out immediately. What will we use as types of instruction? We will use essentially the indexed mode to manipulate different elements of an array. In this example, we have an array, named T, with 5 items. T is considered as a variable in memory, so, it will be represented by a data address. The first item of T is indexed by 0, the last one is indexed, therefore, by 4. We have used again to perform several additions applied on the elements of the array, a for loop. You can return to my latest videos in the aim to see more explanations. Finally, the program displays a result stored by an element of the array. So, what does this program do? First, the program initializes array items with different values. A for loop performs additions on these items. A result is displayed on screen. That's all. The question to ask now is, how do I convert an array item assignment, since the array is represented by a memory address? It's clear that we need a specific operation code which allows moving data from the accumulator to an index register. In the UAL, several index registers may exist, named by XR1, XR2, XR3, etc. We assume that this specific code operation is move. Therefore, to ensure the instantiation shown in the blackboard, the following steps may be taken in this order. First, we load the index in the accumulator, here 0. Second, we move the index to an index register. Third, we load the value in the accumulator, here 22. Fourth, we use the indexed mode to store the value within the associated array item. By applying the remarks and conventions above, this assembler program may be designed, without optimizations, as shown in the blackboard. The lines written in yellow are comments and these don't have effect on the execution. In other hand, the program doesn't depend of any external values. Therefore, there it will have a unique and single trace. Please follow me, operation by operation, by viewing the value taken by the implied composant. Accumulator is loaded by 0. Index register index 1 is loaded by 0. Accumulator is loaded by 22. Array item with index equals 0 is loaded by 22. Accumulator is loaded by 1. Index register index 1 is loaded by 1. Accumulator is loaded by 14. Array item with index equals 1 is loaded by 14. Accumulator is loaded by 2. Index register index 1 is loaded by 2. Accumulator is loaded by 67. Array item with index equals 2 is loaded by 67. Accumulator is loaded by 0. Index register index 1 is loaded by 0. Accumulator is loaded by 1. Index register index 2 is loaded by 1. Accumulator is loaded by 3. Index register index 3 is loaded by 3. Accumulator is loaded by 22. Accumulator is loaded by 36. Array item with index equals 3 is loaded by 36. Accumulator is loaded by 4. Index register index 1 is loaded by 4. Accumulator is loaded by 0. Array item with index equals 4 is loaded by 0. Accumulator is loaded by 0. The loop variable named I is instantiated to 0. Accumulator content 0 is compared to the constant value 3. Since 0 is less or equal to 3, the next operation to be run is located at 40th memory address. Accumulator is loaded by 4. Index register index 1 is loaded by 4. Accumulator is loaded by 0. Index register index 2 is loaded by 0. Accumulator is loaded by 22. Accumulator is loaded by 22. Array item with index equals 4 is loaded by 22. Accumulator is loaded by 0. Accumulator is loaded by 1. The loop variable named I is instantiated to 1. The next operation to be run is located at 37th memory address. Accumulator content 1 is compared to the constant value 3. Since 1 is less or equal to 3, the next operation to be run is located at 40th memory address. Accumulator is loaded by 4. Index register index 1 is loaded by 4. Accumulator is loaded by 1. Index register index 2 is loaded by 1. Accumulator is loaded by 14. Accumulator is loaded by 36. Array item with index equals 4 is loaded by 36. Accumulator is loaded by 1. Accumulator is loaded by 2. The loop variable named I is instantiated to 2. The next operation to be run is located at 37th memory address. Accumulator content 2 is compared to the constant value 3. Since 2 is less or equal to 3, the next operation to be run is located at 40th memory address. Accumulator is loaded by 4. Index register index 1 is loaded by 4. Accumulator is loaded by 2. Index register index 2 is loaded by 2. Accumulator is loaded by 36. Accumulator is loaded by 103. Array item with index equals 4 is loaded by 103. Accumulator is loaded by 2. Accumulator is loaded by 3. The loop variable named I is instantiated to 3. The next operation to be run is located at 37th memory address. Accumulator content 3 is compared to the constant value 3. Since 3 is less or equal to 3, the next operation to be run is located at 40th memory address. Accumulator is loaded by 4. Index register index 1 is loaded by 4. Accumulator is loaded by 3. Index register index 2 is loaded by 3. Accumulator is loaded by 103. Accumulator is loaded by 139. Array item with index equals 4 is loaded by 139. Accumulator is loaded by 3. Accumulator is loaded by 4. The loop variable named I is instantiated to 4. The next operation to be run is located at 37th memory address. Accumulator content 4 is compared to the constant value 3. Since 4 is not less or equal to 3, this jump will be ignored. The next operation to be run is located at 51th memory address. Accumulator is loaded by 4. Index register index 1 is loaded by 4. Accumulator is loaded by 139. The value in the accumulator, 139, is displayed on screen. Finally, what is the particularity that needs to be seen? Index registers play an important role in program conception because they allow complex structures such as arrays to be manipulated through indexed mode. We have simplified the exercise by taking single-dimensional arrays. But, in reality, the same principle can be applied to arrays of several dimensions. Do you have any questions or comments for me? I am waiting for you in your limited space on my site. I hope this video has been useful and enjoyable for you at the same time. Thank you for watching. Mohammed Balach.